All right, hey, this is Jesse with Create This. So in my last video, I showed you this machine with CPUs only. There were no GPUs in it. And I ran Ollama, and I showed you what DeepSeek v3-0324 can do with Ollama. Well, the overwhelming response to that video was use ktransformers, which is pronounced quick transformers. So I got to thinking about it, and the only thing that I needed to do that was to swap out my power supply. I had an HX1000i in here, so I spent another 350 bucks, $360, something like that, and I put in an HX1500i, and that allowed me to swap in my 3090. So I just had this sitting around. This is an old EVGA hybrid model, so it's got water cooling. I put the radiator over here, so these fans are blowing through the radiator from outside the case. And then I've got my two 120 millimeter fans here, also blowing inward. And I've got two 120 millimeter fans up top blowing out. And I've got a third 120 millimeter fan blowing out as well. I put in this little squirrel cage fan because my LAN chipset was kind of getting hot, but I hate it. It's way too loud, so I've got it disabled at the moment. The other thing that I did is I made sure that both of these fans on the CPUs are blowing up. So before, in the last video, I had basically one blowing up and then one blowing down, and they were fighting each other, and so it wasn't working very well. But with both of them blowing up, this setup stays pretty cool. Let's see what this can do with quick transformers. It's pretty amazing. I have logged into Larry. Let me just start out by saying that this is the video that I set out to make. The first video was disappointing for me. Ollama's performance was not great on this machine. I was expecting better. But this is absolutely what I set out to build. I apologize for the audio quality. I am using my Apple AirPods to record my voice because they are the epitome of convenience. They are not great quality, so I'm sorry about that. If I were just a little less lazy, I would get you some primo audio, but you'll just have to bear with it. So we're logged into Larry. I like to use a screen session because it allows me to disconnect my laptop, close it, things like that, and things stay running. I don't have the startup of ktransformers automated yet. I just do it whenever the machine boots up. I do it manually. I could make a service to do that. It wouldn't take long. I've updated the README. This is from the previous video. So if you want to see where this is, it's at github.com/create-this/Larry. And I've updated this with a ktransformers section. So I'm going to be using version 0.2.4 post 1 of ktransformers. I believe this was released yesterday. This is their new version that supports the multi-concurrency. I have not been able to get multi-concurrency to work. It took me hours to get this to compile, and I was only able to get it to compile with the old ktransformers module, not the balance module. However, they're working on it. I'm sure it'll get sorted out. I don't actually know what multi-concurrency does, but I think what it'll do is it'll allow us to run more than one session at a time. So you'll be able to have like two users using the machine and talking to the AI at the same time. So I've got this little section. There's a guide that you can follow to set this up. It is fairly technical. It is not as easy to install as Ollama. So you're just going to have to suck it up. There's no better way to describe it. There are no binary packages available. It's hard, but it's absolutely worth it. So once you've got it compiled and installed, this is my little guide for starting it. So I'm going to go to ktransformers. I'm going to activate Conda. Conda is like a environment versioning system for Python. It's basically the same thing as NVMe for Node. So I'm going to activate my environment. It's also similar to VENV. That's also another Python one. I have some exports that I do. These are probably not necessary for every execution, but they were necessary once. Okay, now to start it, I think that I have a 128K context window available with this. I'm not 100% positive. I've tested it out past 10K of context. And so the setting that controls this is cache lens. When I had this set to the default, it was like something like 8K. And I absolutely blew that context window when I was using OpenHands with it. So it does something. Uh, I haven't gone past maybe 14K. So I can't verify that I actually have the full 128K available and that it works and that it doesn't slow down. But in my testing so far, it seems to not slow down as you add messages, and it seems to work past 14K. So it's amazing. So I'm going to take this. I'm using DeepSeek v3 0324 today, and I'm using the Q4KM quant. Okay, so 671B Q4KM. I have that located on my data partition here. So I'm going to use the zero point 0.3 temperature, and then there's some other settings. And for the backend type, I'm using ktransformers. I'm not using the balance backend. So let's run this. Now, one thing that I'm going to say is that as I'm running this, you can pay attention to my clock up here. I'm going to speed this up so you're not bored to death, but you can pay attention to the clock up here and you can see how long it actually takes to start in real time. Now, as that is starting up, I'm going to run top so that you can see how much memory it uses. You can see that I've got 765 gigabytes free, and as it loads itself up, we're going to see that rise. And so as it loads, it cycles through the block counts and it loads these in the memory. I have a kilowatt meter attached to my machine as I do this, and I'm just going to read out for you what the wattage is that it's drawing. So it's drawing 615 watts right now. So that's with the GPU installed and everything. I think it's going to pull a little more when it's actually inferring. One other thing while we're doing this, so we're up to 88 gigabytes. I have CUDA installed on this machine, and I can run NVIDIA SMI to see the GPU. So you can see that this is a GeForce 3090, and it's running fairly cool. Wattage looks like 24 gigabytes available. Okay, we're up and running. So that took about 8 to 9 minutes, something like that. Let me show you some things about the API here. So Larry has an Ollama API with ktransformers. So this is the port that I have it started on, that I have ktransformers started on. Larry is an etc hosts alias for the IP address of the machine on my local network. And /API/tags is the endpoint address, the query string. So when I start it up, I get name with the DeepSeek model name, but I don't get model. So if you were using an actual Ollama instance, you would get name and model attributes, but the ktransformers Ollama compatibility API only gives you the name attribute. That's going to make it difficult to use this with Open WebUI. However, this is the cool thing. There is a Open API compatibility API. And this one works just fine with Open Web UI and with OpenHands AI. The other thing that I'll note is that the Ollama compatibility API also does not implement streaming, which makes it not work with OpenHands. The OpenAI compatibility API, for whatever reason, does work. I don't know if it implements streaming and non-streaming or what, but it just works. So that's what I use. Now, let's start up OpenHands so that you can see what that looks like. Oh, no, sorry, not OpenHands, Open WebUI, so you can see what that looks like. Okay, I get these weird errors. They don't keep anything from working. They're just annoying. Exception in ASGI application. It seems to be a Python thing. Scope type equals HTTP. Almost every Python application I have gives this error right now. I don't know if it's like a library that's broken upstream or what. Anyway, so back in the browser, we're going to go to localhost 3000. And here is our Open WebUI interface. They just came out with a new version after I upgraded today, 061. So I haven't installed that yet. I'm going to show you how to configure this with OpenAI, with the OpenAI compatibility layer with ktransformers. So you go to settings here, and then you go to admin settings, and then you go to connections. And if you have an Ollama connection in here, you're going to delete that. And you're just going to configure a ktransformer URL with the OpenAI compatibility API, so the /v1. And then for the key, I just use like Larry or something. You can put anything you want in there. Make sure you turn it on. That's it. Then when you go to the little chat thing, you can say, hello. Look at how fast that is. That was real time. Isn't that amazing? Ktransformers is incredible. Okay, so they don't implement some things, but you do get total tokens, so 211 for that. And then if you want to see tokens per second, you have to come over here to the command line interface where we started the ktransformers server. And here we can see the prefill is 121 tokens per second. And the decode, I believe that's the response tokens per second, 16.97. Absolutely blazing fast, incredible. Okay, let's look at the RAM utilization. So we've got 377 gigabytes used of regular system RAM, and plus our 24 gigabyte GPU VRAM. So we still have 377 gigabytes free on this machine. Absolutely incredible. Incredible performance. That's great, but let me show you OpenHands because this is where it gets really, really incredible. I'm going to shut down OpenWebUI. In my guide here, create this Larry, I have the command for running OpenHands. So the cool thing about OpenHands AI is you can give it, even though it runs in Docker, you can give it a directory, and then it has access to everything in that directory. So if you have a source code project that is written in some language that Visual Studio or whatever your IDE is incompatible with, you can still have the AI iterate on that directory. It's incredible. So for now, I've got it set to my personal directory for the same project that we did in the last video, the Brazilian Jiu-Jitsu calculate match difficulty Boyd belts. Yeah, that's what this is all about. So take a look at that video if you want an explanation of what that's about. I'm not going to go over it again. And then to run it, we just do this command. And so we pass in the workspace directory. It does some magic with the user so that it's when the AI edits files, it edits them as your user. And then it specifies the version of OpenHands. We're running 0.31.0. And we also specify it down here. And we give it the port so that it knows what to start on. Let's start that up. I'm just going to copy and paste this in. I think that'll work. All right, great. It started up. Now you're going to see that ASGI backtrace again. It's just a nuisance. It's not a huge deal. Let me just refresh this to make sure that we are live with OpenHands. We are. Okay, so configuration here is very similar to OpenWebUI. You go into the LLM settings, you turn on advanced, and then for the model, you do OpenAI /DeepSeek -v3 -0324 colon 671b hyphen Q4 KM, right? For the base URL, you can't use Larry unless you set the etc hosts within the Docker container. So I didn't do that. So I just used the IP address of Larry here, and then the port and the same v1 OpenAI API. For the API key, I left that empty. You can scroll down for some additional things. I turned on sound notifications because I think they're really cool. This is such a cool project. Okay, now here's that nuisance error. It just pops up. It's not a huge deal. Now, in this directory, um, I've got my tests, my package JSON, my package lock.json. I've got all of that committed, right? But for the purpose of this test, I'm going to delete them. Okay, so we're going to rm package.json. We're going to rm package lock. We're going to rmrf node modules. We're going to rm the test file. And then we're going to edit the source code, and we're going to make sure that we don't have any exports. So I did a quick test of this system before this, and it added an export. Spoilers. Let's remove that. Okay, and then I'm just going to do a quick git diff to make sure that this is what I'm expecting. So no exports, that's good. No test file. Okay, all of that looks great. So these are the only files that we have in the directory. So we've got the code file, we've got a README, and a git ignore file. All right. Now the AI can see all of that. This is the cool thing. So I have a gist that I've set up, and it just says, this is like my prompt, right? I have a file at bjj calculate match difficulty.js. I'd like you to write unit tests for this file, then make a package JSON, run the tests with npm test, and iterate until the tests are passing. Do not modify calculate match difficulty function. It is correct. So we're going to copy that, and then we're just going to paste this guy right into the prompt, and we're going to run it. Now, this creates a conversation with the ktransformer, and it starts up a container. And it's going to take a little while to do this, okay? So you want to pay attention while this is happening to the clock up here, right? So we're starting at 7:17. However, this is a fully automated process. Once you kick it off, it just goes. It's beautiful. All right. So over here in ktransformer, we can kind of see what's going on as it happens. And over here, we're going to run top, and we can see what's going on over here too. Now I'm going to shut up, and I'm just going to let it do its thing. And I will absolutely speed this up so that it doesn't bore the hell out of you. Okay, so our container, our conversation container has essentially bootstrapped or initialized. We can see that we're using 377 gigabytes of RAM. We can see some things have happened here. And our light has changed from red to agent is running task. Over on my kilowatt meter, I can see that we are drawing 900 watts right now. It's actually spiking up to 930. All right, so the AI has functions available to it through OpenHands AI, and it knows that it can run bash commands. So it's running a find for the code file that we told it about in the prompt. So now it says some output back. I found the file. Let me view its contents to understand what we're testing. So it runs a cat on that file so that it can see it. And I'll just cut over to ktransformers. And so you can see the response streaming in ktransformers, but OpenHands AI doesn't implement streaming, so you can't see the streaming there. Now let's install the dependencies and run the tests. I'll use yes to automatically confirm the installation so that we can't use an interactive shell, as we can't use an interactive shell. Oh, And before that, it created a package JSON. Very cool. Now that we've properly exported the function, oh, wait, before that it says the tests are failing because we need to export the calculate match difficulty function in the original file. So it looks like it uses a diff, or maybe that's the tool using a diff. I'm not really sure. It's probably a tool. That's cool. That's a new feature in OpenAI AI in one of the later versions. It didn't used to do that. The test results show we need to adjust our expectations to match the function's actual behavior. The test file now correctly reflects the function's behavior. And it's done. So 7:23 p.m. That is absolutely incredible. All right, so if we take a look at our file structure here, it created a test file. It npm installed, so it created node modules. It created a package JSON, and npm install created a package lock for us. So if we do a diff against my saved work, we can see how the AI's responses differ. So rather than putting the module exports at the bottom of the file, like we did last time in the last video, it put them on the first line, which I prefer. I think that's cool. Slightly different syntax here in the test file, slightly different test expectations. So it's checking for -0, less than 0, and not equal to 0. So the test expectations are slightly different, but they pass. And package lock stuff is always changing. Like the npm ecosystem is always changing, so that's expected. We'll go down to the bottom. The package JSON is very similar, just some slight differences, kind of what you would expect. It looks like it used Mocha instead of Jest. I didn't specify, so that's fine. I could have specified in the prompt and it would have used Jest. We can run this here in the directory. Tests passing. Absolutely incredible. So back in February, I used OpenHands with the OpenAI API and also with Anthropic's API, Claude, to do real work for my company. Um, I had to upgrade a bunch of Lambdas from an old version of the AWS SDK, I think it was version 2, to the newer version, version 3. And so I had like something stupid like 66 Lambdas, and none of them were using like shared libraries, so they were all like one-offs. And I had to write unit tests for each of them and upgrade them and make sure that the unit tests still passed after the upgrade. It was an absolutely brutal, tedious exercise. And about halfway through it, I started using OpenHands AI, and it bumped my throughput from like 1 Lambda per day to like 7. It was incredible. But it cost me $200 that month in API tokens. This machine can do exactly the same thing for the cost of electricity per day at 900 watts per hour. Think about that. Absolutely amazing. Okay, I hope you found this video interesting or useful. If you're a software engineer, I hope you're sweating a little bit right now because you should be. Thanks for watching and please subscribe.